Good evening, students. Today we are going to learn about the homologous series. We will learn what is homologous series, what are the properties of homologous series. This homologous series is given for each and every functional group. So we will write the four members for each functional group which is belonging to their homologous series along with their name. So this is the target of our today class. A student, if you start with the homologous series, then series we are already knowing. Series is what? Series means the same series what we are learning in our mental ability or in mathematics, the same kind. Means the group which is following certain rule. That was the purpose, that was the meaning of series. Means it is the group following certain rule. What will be the rule in this chemistry? We have to understand it. Okay, it is this one. Student, the beauty of our study is that once you understand a thing, whether in maths or physics or chemistry, the same definition, the same kind of concept is everywhere. So wherever a series means, you shall always think for the group which must have some common characteristic or certain rules. So rules is in term of mathematics, but this rules is given in the term of characteristic in our physics and chemistry. So which following certain rules or have gradation means continuous variation in their properties or have rules for variation in their properties or have characteristic variations also following certain rules. So what is this? So this is the meaning, means we have to learn about certain group of compound, but to whom that we will learn. Another, now coming to this homologous. Homo means always mean the same. Something logous means the family. Means the compounds which are belonging to the same family. What do we mean by the compound belonging to the same family? How the family of a compound is decided? We have learned earlier. It is the functional group which gives the characteristic or which decides the family of a compound or family of a specific organic compound. So it simply means this family is decided by its functional group. Decided by functional group. Because functional group is the atom or group of atom which decides the characteristic of entire molecule. Okay. So if this functional group atom or molecule or this group of atom is kept as it is and the other part, the carbon chain is being varied, then we will get this homologous series. It's so simple. Means collectively we can say the compounds having same functional group, because this functional group decides the characteristic. Okay, so what is the definition of homologous series? Whatever I have explained, let me write the definition. So homologous series always means with same functional group. It is the key thing that you must keep in mind. So for a given functional group, I can have a specific kind of homologous series. So I can have homologous series for alkane, homologous series for alkene, for alkyne, homologous series for ketone, homologous series for alcohol, homologous series for the chloroalkane, homologous series for the carboxylic acid, ether, ester, so and so. Okay. So for writing the definition, so a series of compound with same functional group is called as homologous series. Okay, so right, a group of compound or series of compound, the definition is like this. So a group or series of compounds with same functional group with same functional group. If the functional group is same, then how the compound can differ? By varying their number of carbon atoms present in that molecule or in their molecules. Okay, like methane and ethane, we have learned both contain OH, but methane have only one carbon while propane have 3 carbon. So this methane, ethane, propane, butane can lead to formation of one homologous series, making their derivative like methanol, ethanol, propanol, all these form another homologous series. Okay, student? So group or series of compounds with same functional group and only variation in their, where will be the variation? Carbon skeleton, in their number of carbon in carbon skeleton or carbon chain. In carbon skeleton, or better word for at your level is carbon chain. Okay, student, read this. So this homologous series is obtained by variation in number of carbon. It is one thing in our definition. Another, it must contain the same functional group. So it is the group or series means more than one compound having same functional group will belong to the same homologous series. That is, more than one compound, then one compound having same functional group group. This is the key feature of detecting. So same functional group have to be met, but more than one carbon compound we need to take to compare whether they are belonging to homologous series or not. Okay, students? So this way we have to write example means homologous series is possible for each functional group. Homologous series is possible for each functional group. Okay, student? It is this one. So considering the same functional group, whatever the other compound that can be written, they are called as the members of that functional group. So all compounds or molecules belonging to same homologous series means having same functional group. Are we getting now? Homologous series means homologous series for each kind of functional group. Here I have written homologous for each functional group. So all the compound or member belonging to same homologous series or same functional group are their member. but the starting one is called as their basic or fundamental member. But the starting one means what? Having minimum number of carbon atom is called. This was asked, so that's why we have to understand. The question was asked, write the fundamental member or basic member, or once it was asked as the first member of aldehyde homologous series. Means what? From where the aldehyde can start? Write the first member of ketone homologous series and name and give their UPSC name. This was the question. So I'm going to explain everything in concise manner. So therefore, all the compounds, whatever we are writing, all of them are the member, but one from where this is going to start, which contain the minimum number of carbon atom, is called as basic or fundamental member of that homologous series. Let us understand. So considering this homologous series of maybe your alkane, just wait a minute, let me finish this. Alkene, alkyne, aldehyde, everything we have to write. Say alcohol, aldehyde, ketone, carboxylic acid, okay, even the halo group, halogen group, etc. are possible. Simply. So their first member we have to write, and we can give a general formula for their homologous series. Is possible and can be generalized in formula also. So we will write the formula. So once it was asked what is the general formula for aldehyde, it was asked like this, or say alkene homologous series. Though last I had explained these things, whatever the things that we have written, their general formula we had also written. The same thing I have written. Yeah, ask. Someone was asking something.
So it is same homologous series or functional group?
No. Functional group is the single one. Homologous series with the same functional group, how much member you can write, everyone is falling as the homologous series. Means for each functional group, there will be one homologous series, and that series contain large number of compounds. So write like this, that what I am explaining here. The same thing, your doubt, what you are asking, the same thing I was explaining in this. So what does it mean? Understand this. I may take a functional group. So one, there could be one functional group. Okay. So one functional group, it can give one kind of homologous series. So one kind of homologous series. But this one kind of homologous series have very large number, even million, billion, trillion, how much you can write? that much compound. So having large number of molecules, not molecules, better to write the compound. Number of compounds. So how is this? Let us understand. Okay, student. So say, let me consider what are their properties. I will explain and I will write down them later, but let us understand. There is a difference between functional group and homologous series. A student, if you are asked for, say, simply the functional group simply means the atom or group of atom which decides the characteristic, which decides or gives the characteristic or determines the characteristic of a compound. Understand this. Example. So functional group, if it is asked, only this atom is the functional group. Okay? Only OH, this is the functional group. Only CHO is the functional group. Only this CO, this is the only functional group. Okay? It may be your COOH. These are the functional group. These are functional group. But in itself, it is not the molecule. For conversion it into compound or molecule, it must have to be attached with other carbon chain or with the other carbon atom. So functional group have to attach with carbon chain or with the other carbon atoms and hydrogen atoms to form the compound. Example, if I am just writing CS3 or this one with OH. So what is the functional group present is, if anyone is asked you, what is the functional group? Question is here, what is functional group? Your answer should be only OH with one bond open. Okay, student? But what is the molecule here? What is the molecule or name of the molecule? It is our methanol. Are you getting? So functional group simply means the group of atom. Okay. But considering this one functional group, are you getting this much? Functional group, I have just revised it. Now coming to this one, considering one of the functional group, let alcohol, the same alcohol I am considering. So if anyone is asking to you, alcohol means the functional group here is OH with one open bond. Any doubt to any student, then please ask in between, because once we will go through or finish this topic, then making this understand is quite difficult. A student, if I am talking for the alcohol, what is alcohol? The deciding atom or group of atom is our OH only. Okay. But what is functional group? The answer is OH. But if it is asked, write down the homologous series of alcohol. But the homologous series of alcohol, then this homologous series doesn't mean only OH. Are you getting? It is not only this one. What is that? For this, you have to consider this functional group with carbon skeleton, with carbon, hydrogen, and if there are other atom also there, that one we need to consider. So this functional group must be attached with this carbon and hydrogen to satisfy their valency. Also, it should not be for only one molecule. Maintaining the same functional group means you need to maintain this, you have to vary these two. Varies. Okay? So variation in this carbon atom can give the next member. So varies to get their next members. So at least two or more molecules can be compared whether they are belonging to same functional group or not. So at least, write in bracket. So at least two or more molecule have to be taken. Have to be taken. This is important thing that we need to understand. See, how is this? Now let me write the functional group of alcohol. I have just explained what the functional group of alcohol means, how it will differ from the homologous series and functional group. Example, homologous series of alcohol means you need to keep this OH and vary the carbon chain with which this OH can attach. What could be the smallest one? The smallest carbon and hydrogen atom or carbon chain satisfied with the hydrogen that can be attached with OH is this one. What is this? This is our methanol. Understand? It is the first one. Second one may go for, now this carbon chain length is increased. This one. It is ethanol. Let me write one or two more. If one is taking propanol, let me draw the complete structure. Here we have to take 3 carbon atom, and in that we have to attach OH. So it is our propanol. A student, but regarding this propanol, one may think, why this OH at the end? Why not this should be at the middle carbon? Surely you can draw it. That will be also the propanol only, but the difference is only they are the isomers. Are we getting? So this is being shifted in the middle to get this one. Okay. So this is also propanol. Then how to differentiate this? For that we have learned the UPSC nomenclature. Both are propanol. Both are, what is there? Both are isomers of each other. Isomers of each other. Then how to make the difference in their name? We have learned that for that the position of the functional group have to be written. So it should be propane 1-ol, and IUPAC name of the second one will be propane 2-ol, because you are free to number from any of the terminal for this second structure. In this second structure, we are getting OH is always falling on 2. But in the first structure, we are bounded to count from the carbon where the functional group is attached. Here we cannot start from this end like 3, 2, 1. This will be wrong. Okay, student? More detail we have learned last day. You can go to view those videos once or twice again. Okay, student? It was all about. So what we are getting? All of these are the homologous series of alcohol. So if I talk for the homologous series of alcohol, I need to write the at least any of the two, okay, or at least 2, 3, 4, how much is required, that. Now in this homologous series, the important question which is framed is the two things. One is, what is the fundamental member, and what is the smallest member which can shows or which can exhibit isomerism. This way question is also asked. So here we are getting this first one is, this is our fundamental member, fundamental or basic member, and this propanol, this is the smallest molecule of alcohol homologous series or alcohol family which can shows isomerism. Okay, so this is the can shows, means propane onwards surely there will be isomerism. So can show isomerism, or we may slightly write a bit more. So starting from here onward, means from starting here and onward it can shows you, or it can give this isomers. That is, so these two things are also asked. Many a time it is asked, what is the general formula? Write the 4 members, give their IUPAC name. So here whatever we have written, all of these are our IUPAC name. Last day I had already explained this. Okay student, let me write the 4th member. What will be our 4th member? Just you have to increase the carbon atom. With that you also have to increase the hydrogen, means you need to take the 4 carbon atom, attach this OH, other fill it with the H. So these are the members of homologous series. It is called as butanol. Students, ol, not ul. Here this alcohol group may be at this carbon. If now again if you are bringing it at this carbon with this straight chain, it will not give any new isomers, you can leave it. But the second or third isomers that you can frame, or this can give us the second one, is by placing this over this one, then attaching it one of the end, or placing it here, then attaching it. So the third and 4th isomers can be drawn for this. So this way what we have understood. What is the difference between homologous and functional group? A student, homologous always means certain number of molecules we have to consider, while for the functional group only these atoms we need to consider. Even if we have to name the functional group, we are not writing methanol, ethanol, propanol, but what we are writing is only this much part. So here we are getting all the molecules or all these compound containing the same functional group, but whether they are exactly same, no. Student, methanol has slightly different property than ethanol. We had written earlier also, methanol cannot be used as V-base or for drinking purpose, otherwise it causes blindness. But ethanol is used for drinking, additive as a fuel, and many more. Methanol is used as spirit in our spirit land. Okay, it is this one. So they have different properties, though they are containing the same functional group. So there, this variation is slighter one. I mean, there is slower variation in their properties. not entirely different variation. Means the property of methanol and ethanol, they are slightly changing, but most of the characteristics are same, or most of the properties will be same. Like both of them will undergo dehydration reaction, means removal of H2O. If you leave this methanol, other can from the other molecule or all the other molecule, we can remove the H2O by putting the dehydrating agent like concentrated sulfuric acid. This we will learn tomorrow. Student, so what we are observing? There is variation, or this variation in properties are very, very slow. Most of the characteristic or most of the properties are same. Means all of them will undergo the same kind of chemical reaction. One may go faster and other may go slower, but all of them may undergo the dehydration reaction. All of them may form the ester when reacting with carboxylic acid. So these are the properties, chemical properties. So what we are observing here is that the change in variation, the change in property is variation. Most of the properties are always same. So we are saying that the chemical properties are same, but which property is changing? The physical property. What are the physical property? Like their molecular mass, their density, their state of existence. Like methane is acting as gas, or methane is existing as gas, but this methanol also exists in gaseous form, but not as entire gas. If you leave it open, it can easily evaporate, like a spirit which can evaporate very faster. But this ethanol do not evaporate that much easily. Okay, coming to propanol, also not evaporate. Another thing, considering their molecular mass, methanol have a smaller molecular mass than ethanol than propanol. So this way the molecular mass is continuously increasing. So therefore we can write their physical properties are changing, but chemical properties are not changing. That can be the other conclusion. So all these properties we are going to write. A student, another thing. A student, what we are observing here, that this homologous series of alcohol, each of these must contain the same functional group, and that functional group is our OH. But this one can vary. What is this one? For this methanol, it is our CS3 OH. For ethanol, C2H5 OH. For propanol, it is our C3H, 3 2 is 6 plus 1 is 7. You may count it, OH. Coming to butanol, the molecular formula is C4H9OH. Okay? So here, this methanol, ethanol, or let me write on the next page. Here, methanol, write down the formula, CS3OH, ethanol, C2H5OH, propanol, C3H7OH, butanol, C4H9OH. It is it. We can continue, a student. We cannot stop here. Pentanol, C5H11OH. You can go on writing. Okay. So what we are observing, in every case, if C is N, then H is our 2N plus 1, and this is attached with OH. So this formula is called as general formula. So it is general formula of alcohol homologous series. So right, the general formula of alcohol homologous series is this one. Okay, so this way what we are observing, that homologous series can be expressed in the term of their general formula. So it was also asked once, what is the general formula for alcohol homologous series? It is this one. So all these are the members, and collectively this is forming. It is not only one methane is forming the homologous series. These are collectively forming a group or a series. So collectively means all together form homologous series of alcohol. So if you are just taking propanol and you are saying, is this homologous series? No. You have to tell it could be a member of alcohol homologous series. So this was the meaning. But all of them are containing the same functional group. So functional group simply means the atom. So we can write here, functional group present is, if anyone is asking you the functional group, only you have to write this much alphabet, or this way you have to just write, not as methanol, ethanol, propanol. But if the homologous series is asked, then you have to write few of their member like this. This is the basic or a starting member or first member. This is the second member. This is the third member. A student, likewise, the question is asked like this. Write the seventh member of aldehyde homologous series. Okay, so you have to write down the homologous series of aldehyde. Which one is falling at the seventh? That you have to tell. So here, let me take the second one as simple. The sixth member of say alcohol itself. Write it. Alcohol homologous series. So sixth member means you must understand what is the very basic member, then you have to increase the number of carbon atom. So here we are getting the alcohol, means it must be the OH. For this, the first member is what? Our CH3OH. The second member means first member start with the only one carbon. The second member C2H5OH. The general formula for this, there you can substitute directly the 6. So the general formula for this is our CnH2n plus 1 OH. Therefore, sixth member, you just substitute in this, you can get C6H increase 12 plus 1 is 13 and OH. Many a time it is also asked to draw their structure. Also draw its structure. So many a time it is also asked, draw the structure of their functional group only. Their structure. Also give the functional group present. Functional group present. This thing. Okay? It is like this. So here we have observed that the functional group have to be maintained. Their carbon chain only we have to increase. Now let us go for the aldehyde. Then we will learn or we will summarize their properties. Right. So functional group of aldehyde. Sorry, homologous series of aldehyde, not the functional group. Functional group we have already discussed. Aldehyde. Students, we have learned aldehyde simply means it must contain CHO group. Okay. In the CHO, the detail, if we want to draw, the structure of the CHO is like this one. It is this one. What could be the general formula? So for this general formula, this open bond have to be satisfied with hydrogen or the carbon with hydrogen. So whether hydrogen is possible or not, that we also have to verify first. Students, so here, can we take hydrogen here also? Yes. So hydrogen is also true. Hydrogen is also possible. In this case, it is giving HCHO or COH. It is called as, considering the carbon present in this functional group as 1 for its UPSC nomenclature. It become our methane. E have to be dropped and replaced by ul. Methanol, not ol. Otherwise, it become alcohol. So this is the basic or first member. Now coming for the other. The second one, rather than this, we may attach the CS3 also here. Like this way, or in compact form, this CS3 can be written, CHO can be written. This is how much? 1 and 2. So 2, it is called as ethanol. This is our second member. Likewise, here we are observing this can be increased. But while increasing this, we need to keep in mind for the first member and second member. A student, if we are going to write the third member, this thing we have to compare. So let me copy this for the next page. So this is our second member we have drawn. For third member, I need to increase this. Means C, 2 C of other I need to take. Then COH or C2H5 CHO. It is called as propanol. Which one is this? Third member. A student, what we are observing? For third member, this C of aldehyde is counted even for the second or even for the first. But what is going to be attached here? For third member, the suffix is only 2. So whatever the attachment R that can be written here should be just one lesser than that. Means whatever the N we are taking, CN, H, 2N plus 1, CHO. If we are considering this structure, then from where this N should start? For N greater equal 2. From here we shall start. Or 1 or 0. What it could be? Or 1 or 0. What can be taken? Yes? Student, here you are observing that even this N can be 0, then no carbon but only hydrogen. So it can be equal to 0 also. So for N greater equal 0. So that also we have to understand for writing the homologous series. For N equals to 0, it gives the first member. For N equals to 1, second member. For N equals to 3, third member. Yeah, tell me.
Sir, but carbon is present, no?
That's why N equals to 0 can be taken, no? That's what I am saying. See, this already contains the carbon. So if I am taking N equals to 0 here, then what it become? Substitute here 0. C0, H, 2N plus 1, CHO is already there. Means this no carbon from this other chain, but the carbon of aldehyde itself is there. So only H, then C, HO. So this is our methanol. So therefore, in this case, we can start this homologous series for N equals to 0. But if I compare for the alcohol, can I start this with N equals to 0 here? N equals to 0 if you are taking, then it becomes HOH. Are you getting? Because it is like our C0, H1, OH. It is like our HOH. It is nothing but it is the water. Water is not the member or even not the organic compound. So therefore, whatever this N equals to 0 we can think for, that is not possible. So this implies in this case N cannot be 0. That is, N must be counted from 1. So for N greater equal 1, this is N equals to 1 gives the basic member, N equals to 2 gives the second member, but for our aldehyde, N equals to 1 is not giving the basic member, but N equals to 1 is giving the second member. Are we getting from here? The same thing. Okay, this is for, so therefore the general formula for this can be written as RCHO or CN H 2N plus 1 CHO with N greater equal 0. So once this was asked, the aldehyde general formula is this, then the value of N can be greater equal 0, greater equal 1. Even this was also asked in your MCQ. So here we are getting for N equals to 0, we had obtained this. For N equals to 1, we had obtained this. For N equals to 2, we had obtained this. Means N equals to 2, we are getting the third member. So my question or my intent of saying is that you do not blindly think that N equals to 2 will give the second member of aldehyde. No, you should be careful from where the basic member can start. Like here, for answering this question, I had used, for getting the sixth member, I had just substituted the sixth member. But this thing I cannot use for aldehyde, okay? Because here n can be greater or equal 1. But right here in the same question, in aldehyde, for aldehyde, the general formula is our CN H2N plus 1 CHO with n greater or equal 0. So for sixth member, I shall take n equals to 5. Okay, therefore sixth member is C5H2N, means 2 5s are 10 plus 1 11 CHO. It is this one. This was the crux, or this was the important thing that you need to keep in mind. Many a time our student, either by learning this, just writing a general formula, they are applying this, making mistake. So sixth member means what could be the sixth one? That we have to think. Okay. Yeah, Vivek, any doubt, then please ask what you were asking. Or is it clear now?
Clear, sir.
Okay. Yes, Neeraj, do you have any doubt? Or any other student? So student, you must be careful. First member, you have to observe whether it is possible for n equals to 1 or 0 or even from the 2. For the ketone, we will say on the both side we have to attach. So separately we have to give their Cn H2n plus 1, and next is Cn dash H2n dash plus 1. N may be equal to n dash or may not be equal to n dash. Okay, there it cannot be H or cannot be 0. So those things. So these are just coming from the observations. So student, what? So if it is asked, first 5 member of aldehyde. So let me write first 5 member of aldehyde functional group. Other you will do in your home. I have explained everything. Aldehyde functional group are what they are. A student. So for writing, we need to understand one R and this CHO have to be maintained. In place of this R, it can be H also. So it could be H or R and CHO. So the first member is HCHO. UPSC name methanol. No, AL student, methanol. 2 CS3 CHO ethanol. 3 C2H5 CHO. You can write in this compact form also. 3 carbon are there. Propanol. Then fourth C3H7 CHO butanol. The fifth C4. Here we are getting now. This is fifth, but we are taking here 4. H for 2 is 8 1 9 CHO. This is written as propanol. So this way we can write or we can answer. But here the question is asked like this. Write the first member of aldehyde which can exhibit or which shows isomerism. Also draw their isomers also give the functional group. This is the question. So you should be a bit careful. What is asked? Mostly the question are always indirect. Either definition is asked, that is very simple. Otherwise, in this way the statement is given, you have to understand the functional group and draw it. A student, first member also give their UPSC name. Also give the UPSC name of each. Yeah, tell me. Can any student tell me all of this? The smallest or the simplest aldehyde member which can shows or which can exhibit functional group, sorry, isomerism. Try to think for it, how the isomerisms are possible. Students, it is the simplest one is CHO. It is like this one. The next one is CS3CHO. It is like this one. The next one is, better to first write in this form, CS3, CS2, CHO. The CHO will always remain at end or one of the terminal. The next one is CS3, CH2, CH2, CHO. Now, coming here, one may think that this structure, how is this structure? Basically, it is like this one. CS3, the 3H, let me attach it together. Then CH2, CH2, CHO. If you have doubt, you first write in this form, just a bonding between the two carbon. Now here, you may think, either I can place it at this position. For making the bond here, one of the hydrogen have to be just placed here. So how the structure become? HCH2 means it become like HCH2. This HCH2 is nothing but it is like our, this CH3 I have placed here, CHO. It is like our CH3, CH, CHO, CH3. It is the one way one can think for making the isomerism here. Yes, it is possible. One of the structure is the simplest one or the straight one. Other is this one. If one is thinking to move this functional group at this point, will he get same structure or different structure? It means CS3 will be here, but here CH and CHO will come here. And this one of the hydrogen have to attach here. So it become like again CS3. Here we are getting, a student, the straight chain is like this one. Here also we are getting the same thing, students. It is like our this one. So just a turn is nothing but it is the same carbon. So these two are identical. Getting now? These two are same. So here the question was, first member of aldehyde which can shows isomerism. So what is the answer? So it is the first member of aldehyde which can shows the isomerism. So first this one you have to write the UPSC name also. By changing this, the other structure that we have drawn is either this one or this one. Whether you have drawn it by first changing the methyl group at the carbon containing aldehyde or changing this aldehyde itself to the middle carbon, both will give the same result. Get it? So write the structure. So write the answer to the point answer whatever you have to write. No need to do this much, I had explained it, but just by practice you please do this much in your rough work, whether it can give or not, if you have the doubt. So first member which can give the aldehyde is, what is this? Is our butanol. So the first part is our butanol, is our butanol. The second part is draw their structure or their isomers. So isomers I have drawn here. This is the first one and this is the second one. So draw only these two. For the second, you have to draw the isomers. You can draw in compact form also or in this open form. CH3, CH2, CH2, CHO, and the other one is CH3, bringing the CHO in between. It becomes like CHO, then it is our CH3. The second part is over. You have to write only this much. Coming to the third part, give the functional group in each. What is the functional group? So the functional group is, you have to draw this one only, CHO. Or if you wish, you may draw this structure. It gives better impression that a student is knowing the structure. Okay, it is this one. So these are the ways by which you can answer. So you have to write this simplest thing. Yeah, what else is there? So give their functional group is over. Give their IUPAC name. I am writing the IUPAC name here itself. IUPAC, if it is asked, then you must keep in mind IUPAC of both you have to write. Okay, student? So what will be this? 1, 2, 3, 4. So IUPAC name will be simply butanol, because the carbon of the CHO is always counted as 1. Coming to the second. For this, can I take this as the carbon chain? Yes or no?
No, sir.
Other student not able to understand? Can I take this carbon chain as not for nomenclature? No one is knowing. You please go through your previous videos here.
No, sir.
Good. So first we have to understand wherever the carbon containing functional group, that have to be surely considered and we have to start. So this indicate I have to start from here. Then reaching to this second, I have two ways, either this way or this way. But here we are getting both are giving the same length. Okay, 1, 2, 3 or 1, 2, 3. So we are free to choose any of them. So let me choose this way itself. Then in this case, the other will act as alkyl, means as prefix. So it is the structure for methyl, and this have to be added before this. And since this aldehyde is always present at the end or the beginning, so one Al is not required. So right, it is our methyl. What is this? How much carbon? 1, 2, 3. So it will be propanol. A student, no need to write this 1L because it is defaultly it is at 1. So 1 is dropped here and directly propanol is written. Okay. So one name is this, and this was our butanol. Okay. Direct counting of the carbon. We have reached to butanol. Students, any doubt then please ask. Otherwise, I had explained all the possibilities how the questions are framed. What is functional group? I will now write the properties of functional group. Okay, student? So you have to write the answer to the point. So butanol, this one, this is the structure. Then if functional group is asked, so this one. Only this much you have to write. For your explanation, I had given or I had drawn the earlier structures. Okay. So in your notebook, you just write this much. If you have doubt, please do this thing. I mean the extra structure or thinking in your rough work or at the rough space. So this was all about. Students, now let me enumerate the properties of functional group. Students, here we have learned it contain properties of homologous series, not functional group. Huh? Homologous series. So a homologous series must be given for a specific functional group, means it contain same functional group. And for each functional group, there could be homologous series. Like homologous series of aldehyde we had written, homologous series of alcohol we had written. Okay, that was the first one. So contain same functional group. It is this one. Another, coming to the other properties. Their physical properties like mass, melting point, boiling point, these things are varying. But chemical properties, means tendency to react with the other, always remains the same. Means properties of homologous series means properties of members of homologous series. Are you getting? So their members have different physical properties What are these physical properties? Like their molecular mass. Write in the bracket. Many times our students are not understanding this. Their melting point, their boiling point, their state of existence, whether it is existing as solid or liquid or gas, their density. Yes?
Sir, but alkane does not have functional group, but
Pardon?
it is homologous series.
Pardon?
Sir, alkane does not have functional
Alkane
group.
itself is considered as a group, okay, or alkyl group. Getting no? That is the very basic. So alkane we are not writing as a functional group, but for the homologous series we can write the different member of alkane. Means even without functional group, it is possible. That is the only exception. Otherwise, we always have to be considered for the functional group. So better you want to complete this. It contains same functional group excluding, yes, add that word, excluding alkane. A student containing carbon-carbon single bond only, that itself give one property. That is also functional group. But functional group is not defined from that way. Functional group is defined from the alkene, which have the double bond, or alkyne, or the atom or group of atom, these things. So students, the member have same physical properties, but different physical properties, but same chemical properties. Chemical properties. Same chemical properties means students, they will undergo same kind of chemical reaction. That is, all their members undergo same chemical reaction. Excluding few exceptions, like for methane, null dehydration is not possible because in one carbon the double bond cannot be formed. Okay, so that exceptions we also have to keep in mind. So it undergo same chemical reaction. Now third one, if we consider the physical properties, then continuous variation are called the succeeding members. So succeeding members differ by which unit? CH2 only. This can be observed from here also. Observe here. Student, what is here? It is CH3, CHO is present here, CH3, CHO is present here. While moving from the first member to second member, or even the second to third, what we are observing here? Only this CH2, this is being added. Moving to this one, means compare with this one more CH2 is added. So moving to the successive. Successive means you are comparing, if you are considering the first, you have to compare with the second. Successive, if you have taken the second, then you shall compare it with the first or the third. They are the succeeding. So if you are considering the second, either you shall consider with this third or with the first. From first to second, it is also CH2. How? A student, from here to here, one H is here, then it becomes CH2. Are we getting? So exactly every time the successive member differ by CH2 only. So right, successive member or adjacent member, sometimes also called member or adjacent members, just either preceding or succeeding members differ by the CH2, means only this much part, CH2 unit. Okay, example, whatever the functional group you want to take, you can take it. Say I'm considering HCHO, or let me take the acid this time, COOH. This is fixed. Other will be what? CH3, COOH. Is these two are differing by how much? Student, this you can understand. H, C, 2H are here, but let me write these two H together here. Means after this C, then COOH. This way it becomes visible to you that the next group, this is the first group, sorry, first member of carboxylic acid, this is the second member, it differ by only this much amount. If I am coming to the third member, it will be our CH3, another CH2 will come here, then COOH will be here. So again from this to this we are getting this is being added. So this way their succeeding or preceding are always differing by CH2 unit. Okay, students? Now see, what is this CH2? CH2, these have how much mass? 1 carbon means 12 and 2 hydrogen plus 2 means 14 AMU difference. So in term of mass, we can write succeeding member or adjacent member differ by CH2 unit or by 14 AMU in their mass, in their molecular mass. These two properties may be written separately in many of the books, but I have collected. So 14 in their molecular mass, but for CS2 unit, where this CS2 unit were in their molecular formula. Let me rewrite it like this. So differ by the student, write like this, by the CH2 unit in their molecular formula. Means this is the molecular formula. What is the molecular formula? You can calculate 2 hydrogen, 1 carbon. Carbon is 12, oxygen is 2, O2 means 16 into 2, 32, plus 2 hydrogen is there, plus 2, you can get this as 46 U. This is the molecular mass. Now coming to this, what is the molecular mass of this? For this, the molecular mass will be CH3. You may write like this, 2 carbon. So 2 into 12 plus oxygen is also 2 into 16. Now hydrogen is total 3 plus 1, 4 hydrogen is there. So that is our 4. So you have to just add it. You will get 24 plus 4 is our 28 plus 32. It becomes 60. 60U. Now if you are subtracting this 60U, or if you are taking the difference of 60U and 46U, 60U minus 46U, again you are getting the 14U. So this is the meaning of their molecular mass differ by 14 AMU or 14U, but their formula differ by CH2. This was all. These are the 3 important properties. So their molecular formula differ by CH2, but molecular mass differ by 14, because this CH2 unit have the mass 14, and even we had also calculated. These are the 3 important properties. Now let us stop the class here. This was all about our functional group. Everything I have explained. Now students, what are different functional group for different, what are the different homologous series for different functional group? Here it is written. Ready? So it is the homologous series for different functional group. Along with the name and everything we have written here. So here we are observing all the properties are satisfied. What are their UPSC name? What is their structure? Whether isomer is possible or not? Everything I had explained. Okay, student. So you have to redraw this table. I think yesterday I has also given you to draw up to the 10 carbon, but I do not know how much of you have done or not. So what are their functional group present? Say for alkene, what are the homologous series? It will be the ethene, propene, butane, this one. Coming to the other one, say for alkyne, if you want to mark, ethyne, propyne, and butane. It is. From butane onward, isomers are possible. Similarly, for the halogen, we have taken the chlorine and bromine, we have written the different name. So these are the series. Means for each one, if you are going vertically downward, it will give you homologous series. Okay, so this is means going this way downward, it is the homologous series of alkene. So I'm not going to redraw this. I had already explained yesterday, and after explaining various properties, I have shown you. You please do this. So whatever the things that we have learned, you have to practice more regarding the aldehyde. Aldehyde we had run, and this alcohol we had run. Regarding the acid and this ketone. For ketone, on either side you have to take the methyl group and you have to observe. A student, for the ketone, again coming to the ketone. For the ketone, what is the fundamental member or basic member, a student? It is our propanone. This is the fundamental member or basic member. Are you getting a student? So in this case, this is asked many times. What is the basic member or first member of? This is the first member of ketone homologous series. Are you getting? So these things you have to keep in mind. Which homologous series will start with which member? But aldehyde and ketone, even for n equals to 0 is, sorry, for aldehyde and carboxylic acid, n equals to 0 is also possible. Okay, student? So observe this table carefully. I have explained everything. So this was all about our homologous series. We are left with only two more topics. One is the property of hydrocarbon, like their physical and chemical properties. So addition reaction, substitution reaction, elimination reaction, this thing. And next one is soap and detergent. I think two more classes are required. After that, we are able to finish this. So students, shall we stop the class? I hope we shall stop. But what could be your homework? Write down the homework. Write the 5 members starting from their basic one. Okay, 5 means from beginning. Of this homologous series, also give their UPSC name. Please practice these questions along with functional group. The functional group that I myself is writing in the term of functional group itself. The first one is our chloro group, chloride. All right, for the chloroalkane, chloroalkane. Student, it may be possible to form homologous series for more than one functional group present in same molecule, but those things are not in your scope. like alcohol or aldehyde attached with alkene and alkyne. So these things are not in your book. So we are not considering that. The second one is carboxylic acid, acid. 5 members you have to write. You also have to write the name. Okay. Ketone also. For ketone, you will vary both sides. Okay. Once you will vary on one side, another on other side. I have already written the 2 or 3 members in that table. So please do only this much. This much is enough for it. Yeah, student, any doubt then please ask. Otherwise, we shall stop the class. Still today we have gone a bit long. Yes, students, any doubt? No doubt?